Now, if you become a geographer, you'll need a basic understanding of rocks because that's how you'll get to know the landform and probably the Earth's surface. So, rocks are categorized under three families on the basis of the mode of formation. They are igneous rocks, sedimentary rocks, and metamorphic rocks. Let's understand each one of them. So, the first one is igneous rock. Now, igneous rocks are formed out of magma and lava from the interior of the Earth. So magma is also called molten rock, and it is found in the mantle of the Earth. If you remember this pic showing the different layers of Earth, mantle is filled with magma, and when magma comes out of the surface, it cools down and becomes solid. That's how the igneous rocks are born. Now igneous rock is also known as primary rock because it is formed from magma, so anything that is formed right from the core ingredient of the Earth has to be called as primary rock. The word igneous is derived from a Latin word called ignis, which means fire. Now, mantle is filled with magma, and when magma comes out of the surface, it cools down and becomes solid. That's how igneous rocks are formed. So, mantle is in a way a fire. The process of cooling and solidification can happen both in the Earth's crust as well as on the surface of the Earth. We now know that igneous rock is formed from cooling down of magma, but you need to understand this. When magma comes out of the mantle, it can sometimes just stay under the crust. It need not get out on the surface. Sometimes magma just cools down under the crust itself. That's why during open cast mining, large chunks of igneous rocks are found. Igneous rocks are classified based on texture. When we say texture, we mean something like this. Look at the color as well as design pattern. And this texture depends upon size and arrangement of grains or other physical conditions of the materials. So if you remember while reading about physical properties of minerals, there we read that the external shape depends upon the molecular arrangement of crystals within. So rocks are these tiny soil debris packed together, and depending upon these debris, the color of the grains, overall external look will be dependent on it. If molten material is cooled slowly at greater depths, mineral grains may be very large. Sudden cooling at the surface results in small and smooth grains. Remember the third point where I said sometimes the magma cools down under the crust itself and does not really comes out on the surface. So when magma cools under the crust, it does become solid, but it does not get exposed to the external weathering agents like wind, river, and ice. Because of that, the mineral grains do not break, they are intact. And as it is, there is a huge amount of pressure under the crust, and plus temperature is not normal too. So in this situation, those igneous rocks that are formed under the crust or in deep depth of the earth, they tend to be very large in size. It's like as long as the rock is under the earth's surface, the pressure and temperature doesn't let the mineral debris to split apart. It keeps them intact. The intermediate conditions of cooling would result in intermediate sizes of grains making up igneous rocks. When you look at the rocks that comes under igneous rock, I'm talking about granite, gabbro, pegmatite, basalt, volcanic breccia. All these looks different in terms of texture and composition. And it is because of the fact that all these rocks have evolved with different conditions. I mean, some cooled early, some late, some faced more pressure, some faced less, conditions like that. After all, two products will look different only if there is a change in their process of formation. How else can they be different then? So this was about the igneous rocks. Now we move on to the second type, sedimentary rocks. The word sedimentary is derived from the Latin word sedimentum, which means settling. First of all, sedimentary rocks can be easily broken down into tiny sediments of mud and soil debris. They also have the tendency to settle down in the Earth's surface easily. Rocks of the Earth's surface are exposed to denudational agents and are broken up into various sizes of fragments. These denudational agents are also referred to as exogenous forces like wind, water, ice, etc. These forces over the time erodes the rock and breaks it down into small soil debris. It happens to all types of rocks, that is igneous, sedimentary, and metamorphic. Such fragments are transported by different exogenous agencies and deposited. These deposits through compaction turn into rocks. This process is called lithification. Now this process is also known as the rock cycle. I've made a video on it, do check it out. Nature has such nice way of performing this rock cycle. Rocks are eroded with the help of exogenous forces like wind, air, ice into tiny little soil debris. These debris, they move from one place to another again with the help of the same exogenous forces. Now these small fragments gets deposited in the form of layers and layers one after another. This process creates pressure that is called compaction, and as it is, there is good amount of heat under the crust, so it becomes all the more easier for these debris to develop into a full-fledged rock. This process is called lithification. In many sedimentary rocks, the layer of deposits retain their characteristics even after lithification. Hence, we see a number of layers of varying thickness in sedimentary rocks like sandstone, shale, etc. So if you look at shale and sandstone, here it is, notice there are line patterns depicting layers. So these are the layers of deposits. They are very much visible. It is not visible in every sedimentary rock. Now, depending upon the mode of formation, sedimentary rocks are classified into three major groups. The first one is mechanically formed. When we say mechanical, that means it follows a natural pattern. How rocks weather down, then becomes tiny soil debris, which later on with accumulation and compaction becomes a rock again. So this is a natural cycle, also known as mechanical cycle. Now, when we say organically formed, we mean rocks formed from organic debris such as leaves, roots, and other plant or animal material. You see, limestone and coal contains fossils, and that's why they are organically formed. And when we say chemically formed, we mean rocks formed due to precipitation of minerals from water. Precipitation is the creation of a solid from a solution. If you see, how is halite, potash, and limestone formed? Millions of years ago, evaporation of seawater led to the formation of these minerals. So this was all about the sedimentary rocks. Now we go to the last division of rock called metamorphic rock. The word metamorphic means change of form. Just like metamorphosis, where a caterpillar transforms into butterfly, so the word meta means change in other form. Now these rocks from under the action of pressure, volume and temperature changes. Rocks are as it is so hard, and to change their form, just imagine how much of pressure and temperature is required. So it needs incredible amount of pressure and temperature. So in the previous point I said metamorphic rocks require great amount of pressure and temperature. The question is where and how will the rocks get the pressure and temperature? So you see, the tectonic movement is referred to as the movement of plates on which oceans and continents reside. When two plates come closer, we call it as convergent boundary. In convergent mechanism, a smaller plate subducts under a larger plate. With this, all the rocks that is sedimentary and igneous moves towards the mantle, that is under the crust. That's how pressure and heat influences the rocks to become metamorphic. Metamorphism is a process by which already consolidated rocks undergo recrystallization and reorganization of materials within original rocks. So this recrystallization and reorganization of a rock happens due to extreme heat and pressure. When the rocks make their way inside the mantle during subduction, heat and pressure acts on them and transform them into metamorphic rocks. Now the transformation of metamorphic rocks happen in two ways. One is through dynamic metamorphism and the other is through thermal metamorphism. Let me cover these 2 points together. Now rocks undergo dynamic as well as thermal change. So one is due to pressure of the massive weight of the landform and the other is due to heat from the interior of the earth. It is very easy to remember this. In chemistry, if you want to separate the elements from a mineral, you basically heat it to a point that it melts. So thermal metamorphism does chemical alteration to the rocks. Now under thermal metamorphism, they are of two types. One is contact metamorphism and the other is regional metamorphism. To understand this, I will do an illustration. So far we know that rocks make it to the interior of the earth due to tectonic activities, right? Now when the rocks are under the crust, the contact metamorphism refers to the point where these rocks come in direct contact with hot magma and lava. So this is going to melt the rocks and recrystallize them in different form. So this is contact metamorphism. Now in regional metamorphism, the rocks do not become molten rocks in order to change their shape. They just need the incredible pressure of the landform above and high temperature as well, but do not mistake it with molten form. It need not melt the rock. That's why contact means in touch with magma and regional means around the magma, so that heat of the magma does the trick. In the process of metamorphism in some rocks, grains or minerals get arranged in layers or lines. Such an arrangement of minerals or grains in metamorphic rocks is called foliation or lineation. Now have a look at this picture. You see this horizontal line, nice clear pattern sort of a thing? This is called foliation or lineation. Imagine how much of pressure this rock must have gone through so that layers are visible. Now in the similar manner, we have banding, where layers appear in light and dark shades. They will not have a clear pattern, but still you will see different layers of shades. That's why this is also called as foliation. Now types of metamorphic rocks depend upon original rocks that were subjected to metamorphism. Metamorphic rocks are classified into two groups, foliated rocks and non-foliated rocks. We have read about what are foliated rocks. So under foliated rocks you will see a nice clear pattern sort of a thing, and then you have a banded rock. But the non-foliated rocks looks like this. You'll see random patches of shades. Basically it looks like an ugly rough rock. But you will not at all find any layer. That's how you can recognize foliated and non-foliated metamorphic rock. If you want to see more of such educational content, make sure you're subscribed. By doing so, you'll get an alert when my next video comes. Thanks for watching, and I'll see you in the next one.